Bright Duty. Every student matters.
Hello students, my name is Sanjay Jain. In today's lecture we will start the chapter of statistics. This chapter is an interesting chapter and it will go a long way with you if you understand it well in this class. Right? In class 9th or in the previous classes you have learnt about representation of data in terms of bar graphs, histograms, etc. Right? And then we calculated some of the terms like mean, median and mode for ungrouped data. Right? Mean, median and mode are known as measures of central tendency. So we talked about that in class 9th. Now in this class we will specifically talk about mean, median and mode of grouped data. Right? Before starting that, let us revisit some of the concepts. First general point that I want you to consider here is, let us say there is ungrouped data of marks of a student, right? Let us say one student has got 15 marks, another student has got 18 marks, then 21, 25, 32, 39, 43, 45, 47, right? And then another student has got, let us say 25, one more student has got 43, then 39, then 21, 25 and 21. Let us say these are the marks of students in a particular class. Okay. Let us say these are class 10th students marks. Okay. These marks are out of, let us say, 50. All right. Now you notice that 25 appears 3 times here, right? So rather than writing 25, 25 and 25, I can write 25 is 3 times, right? 25 into 3 times means 25 into 25 means 25, 25 and 25. Rather than writing it 3 times, what I can say is that 25 appears 3 times in this data. So this 3 times is its frequency, right? This is the marks of a student, right? And this is the frequency, right? That 3 students have got same marks, which is 25. Similarly, if you look at 21, what is the frequency of 21? It is again 3, right? 39, if you notice, 1, 2. So 39 is obtained by 2 students. If I need to write it in mathematical terms, I will write it as xi and this as fi, right? So 39 has got the frequency 2. Fi means frequency of data, which is xi. For example, if I write x1 here, okay, and x1, let us say in this example, is 21. Okay, so if I take 21, then what is f1? F1 is the frequency of this data, which is 1, 2, 3, right? So frequency of 21 is 3. So writing in these terms makes it a little simpler, but to make it further simpler, what we can do is we can divide it into classes. For example, let us say 10 to 20 marks, 20 to 30 marks, 30 to 40 marks, etc. Now, how many students have got marks from 10 to 20? 1, 2. So, the frequency of this class is 2. Okay. How many students have got marks between 20 and 30? 1, 2, 3, 4, 5 and 6. So there are 6 students who have got marks between 20 to 30. Okay. And between 30 to 40, 1, 2, 3. 3 students have got marks between 30 to 40. And what about 40 to 50? 1, 2, 3, 4. So 4 students are such who have got marks between 40 to 50. So now if I have written it in this form, this looks neat now, right? Rather than writing it in this form, if I divide it into classes, it is simpler for us to interpret this data. So the statistics is all about interpreting a certain data, right? So to interpret it better, we will try various forms to write data and understand about data. Okay. Now let us learn some of the things. That what is class? This 10 to 20 is a class here, right? And what is class length? It is 10. This is the upper limit, this is the lower limit of the class. So what is class length? It is upper limit minus lower limit, right? And we will maintain equal class lengths, 10 to 20 and then 20 to 30, right? And this one is upper limit, this one is lower limit. Now you need to take care that the upper limit is not included in that class. So if some student has got 20 marks, he will not be in this class, he will be in this class. Similarly, if a student has got 30 marks, he will not be counted in this class, he will be counted in this class. So the upper limit is not included in that class, right? So this was point number 1. Let us look at other point here. Point number 2. Let us say I have got 5 entries, x1, x2, x3, x4 and x5. Okay. What will be the mean or arithmetic mean of this data? You will simply add these and divide by number of observations, which is 1, 2, 3, 4 and 5. So this will be the arithmetic mean. This is a simple concept that you understand from your previous classes also. Now what I want to notice here is, let us say if I subtract a number a from each observation or each entry, whatever you want to call it, right? Now what effect will it have on the mean, right? So x1 minus a plus x2 minus a plus x3 minus a, I need to subtract it from each entry. x5 minus a divided by 5, right? This is not equal to this, right? I am just trying to show you how it will affect our mean, right? And then we will adjust it accordingly to equate with this arithmetic mean. And you will tell me what to do to equate this with this arithmetic mean here. Now you see 1, 2, 3, 4 and 5. So 5 A's are getting subtracted. Okay, now look at the effect. x1 plus x2 plus x3 plus x4 plus x5 minus 5a, right? And it is divided by 5. So look at the first part, x1 plus x2 plus x3 plus x4 plus x5 divided by 5 minus this 5 will get cancelled, right? So it is minus a now. Now if you have noticed carefully, I subtracted a from each of these entries, right? And tried to calculate the new mean, and the new mean is lesser by a, right? This is the previous mean and the new mean is lesser by a. So if I add a here, it will just be equal to the previous arithmetic mean that we calculated. So what is the observation? What is the outcome, right? What is the takeaway from this? That if you subtract some number from each of the entries, right, and then calculate the new mean, right, it will just be lesser by the same number that you subtracted. So you finally add that number and it will be equal to your original mean. Now why do we do this? We may have to do this to make the calculations simple. Let us say these numbers are very big, x1, x2, x3. and it will be difficult to calculate using these big numbers. So we subtract a certain number from each of these entries, and finally when we calculate the new arithmetic mean, we can add this number to calculate our original arithmetic mean, right. So this is the observation that I wanted to highlight here. Another observation that I want you to notice, that if you divide these numbers, let us say x1 minus a divided by h, x2 minus a divided by h. Similarly, keep on dividing by these entries by h. Now if you want to calculate the mean, what will be the difference from the original mean? This 1 by h can be taken as common, right, and inside you will have this term, which is nothing but the original arithmetic mean minus a, original am minus a, right. So if you just multiply this by h, this h will get eliminated. Now finally you add a, then you will get, it will just be equal to the original arithmetic mean, right. Why I am telling you this is that when we study about mean, we will study some shortcut method, assumed mean method, right, and then we will study about step deviation method. So these concepts will be used there. What are the concepts? That if you subtract a certain number from each of the entries, the new arithmetic mean will just be lesser by that number from the original mean. So if you add that number in the new arithmetic mean, you will obtain the original arithmetic mean. Similarly, if you divide each entry by certain number, okay, then finally you will have to multiply by that number to come up with the original arithmetic mean. I hope you understand this concept. One more concept that I want you to understand here is, this is about a new term here. This term you have seen previously also. This is a summation sign. This means summation, and this sign is known as sigma, right. What is the meaning? Let us say you write I equal to 1 to 5 here, and if you write I here, right, what is I? I is summation variable, right, and this 1 is the lower limit and 5 is upper limit. Now what does it mean? Summation means sum, okay. So how will you expand it? Look at the summation variable. Summation variable varies from 1 to 5. 1 is the lower limit, 5 is the upper limit. So when you go 1 to 5, you have to consider all the integers 1, 2, 3, 4 and 5. Okay. So first you put I equal to 1 here and then add, because it is talking about sum here. We need to take sum of these entries. How? By putting I equal to 1 first, and then we will put I equal to 2. So add 2, then sum I equal to 3. So 3, 4 and 5. In this case the expansion will be this, right. Let us take something else. Let us take I equal to 1 to 5 and then inside we take 3i, right. So from this summation, this is the summation variable, this is a constant for this. So what you can do is you can take this outside this summation sign. Now this you know how to expand, right. So if there is a constant term in product form here, we can take it common or we can take it outside. Otherwise also if you expand it as it is, it will be expanded like this: 3 into 1, 3 into 2, 3 into 3, 3 into 4, 3 into 5. Then if you take 3 common, you will arrive at the same result, right. And some of the cases this variable might not be given, but you need to understand. Let us say you are given fi xi, I varies from 1 to n, okay. What will be the expansion? You put I equal to 1 first, f1 x1, then plus I equal to 2, f2 x2, then plus sign, f3 x3 plus sign, and go up to Fn xn, because this is the upper limit here. Okay. Now in some of the cases you might be given like this, fi xi, because I will use some of the formula in this chapter where I will write sigma fi xi. Now it is understood that I varies from 1 to n. Okay. So whenever I write this, you need to understand this. Okay. So we will talk more about sigma and its uses while we progress with this chapter. So this was about these things. Now if you want to calculate arithmetic mean, okay, you need to just add all the entries. Let us say there is x1, x2, x3, x4 and x5. Okay. For arithmetic mean, what I will do is simply add these and divide by 5. Okay. Now if x1 is present f1 times here, okay, from the example that I took, let us say 21 marks are obtained by 3 students. So how will I write that here? 21 plus 21 plus 21, or what I can write is 21 into its frequency, which is 3. These two things are same, right? So similarly, if x1 is present f1 times, x2 is present f2 times, and similarly xi is present fi times. Now I can be replaced with any of these 1, 2, 3, 4 and 5 here, right? So how will you calculate the arithmetic mean now with these new frequencies? What I will do is I can calculate it like this, f1 into x1, right, f2 into x2, or what I can write is sigma fi xi divided by sigma fi, right. What will sigma fi signify? It is sum of, it is the total entries, right, total number of observations. For example, 21 is present 3 times, 24 is present, let us say 2 times. Now the frequency of this is 2, frequency of 21 is 3. If I add these 3 plus 2, it will give me 5, which is the number of entries 1, 2, 3, 4 and 5, right. So sigma fi will give me the number of entries, okay, and which is the arithmetic mean. So I have added all the data and divided it by sum of the total number of observations, which is sigma fi. Okay.